webinar once from our side. So we participated quite a few times in the last 1-2 years, and it was always interesting to have an insight in different companies and other topics. Fast. Yeah, so I need to scroll like this. Okay, so Christian already introduced us quickly. Maybe if you...
Also, hello from my side. I think, Christian already mentioned some background of my person and also from Nicolas.
Yeah. So already almost 9 years, so together 9 years at Hess, some experience in our application. Maybe quickly some introduction from Hess side. So it's already a long story. It was founded in 1882 as like a bodywork company that was building bodies for cars, passenger cars, and then later for buses. Started in 1940 with the first electric buses for the city of Biel and Basel. So especially the body of the buses came from Hess, and then we stayed always innovative with technologies like the Cobalt system that is used for thousands of airport buses, and introduced double articulated buses in early 2000 years, and then a major step in 2016-17 where we first time acted as a OEM, complete vehicle manufacturer, where we also, or nowadays we are also responsible for the whole vehicle. We are doing chassis engineering, traction system engineering, to build a complete bus, electric buses. And then also in 1 year ago or 18 months ago, we built the last diesel buses. So the era of internal combustion engine is already over in our company, and only focusing on electric vehicles. Here you can see again some facts and figures from the company. So around 650 people working around Switzerland mostly, and also some of them in Europe, and a handful in worldwide for Hess. We have bus productions in Bellach, where we can build complete buses, and also making assemblies in Portugal. We have projects also as employees, mostly in Europe. So focus on markets like Switzerland and France, but also having projects around the world. So we also delivering complete transport system to Australia, and maybe can get some insights in the next 20 minutes in our slides. Maybe what is interesting in the numbers is that we are growing from production side. In the last 5 years, we had around 50 to 100 vehicles per year that we produced, and now we are quite happy that we can grow, and doubling the production capacity in the next 2-3 years, up to around 200 vehicles per year. This is the goal for the next years. From battery side, maybe this interests you all. 8 MWh sounds not like very much, but this is also one reason is also that we are using quite a specific technology, and where we don't need too much kilowatt hours, but we need like a high performance battery for our buses. Again, some introduction from our platform. So we have one vehicle platform. This is called LightTram. So the customer has a lot of advantages from a tramway. But also like advantages combined from bus world and light tram, or from tram world. This is our product, so we can scale it from 10 to 25 meters. And then we are also focusing on charging technologies and on different battery technologies. And another focus or another added value that we have in our vehicles is that they are built for up to 20-year lifetime. Compared to other manufacturers, this is quite a long time. So normally buses, diesel buses or other electric buses are designed for 12, 14 years. But from Hess buses, also with the experience from trolley bus applications, it's always foreseen that the buses can live up to 20 years. We have some examples where the buses are in operations already for 30 years. Yeah, and most of the structure is recyclable. So we have this big aluminium cobalt structure of the body, steel chassis, and a lot of components that are recyclable. Yeah, and here again, some insight of the vehicle concept. So what we are really focusing on is that we are building buses that are, we would like to transport passengers also in the passenger compartments. So no technology, no battery towers, no motors, no technical stuff in the passenger compartment. So should allow a lot of space, a lot of movement in the passenger area. Also the view on the back window. So normally there is some kind of motor compartment for other buses, but this is really one of our advantages that we give the passenger compartment to the users of the public transport, and don't waste it with technology inside the passenger compartment. So all the technology, all the traction components, air conditioning, is everything placed on the roof, including batteries and AC units. And this allows good maintainability, good passenger flow, and good lifetime of the whole vehicle. So this was a little introduction into the bus world. Now we try to make the switch to the battery and charging topics. So this slide is, from our perspective, a very important one, and this is also a little bit the story of the next 50 minutes, that we can somehow show you with what battery and charging technologies we are making our products, or which technologies we are using to make to build our products. And what we can see here are two axes. So one axis is one-to-one diesel bus replacement with electric buses, and the other x-axis is the cities with advanced charging infrastructure. So we see here some fields, especially in this left and right area of the diagram, that on the right side of the diagram you can imagine like cities that already have a good charging network with trolleybus catenaries, or also with charging stations, with electrical a good electrical network with sufficient energy at the terminal stations. And on the other hand, you can see cities that don't really have this infrastructure, maybe a little bit more operators that are in areas not that dense or not that urban. And it also shows that for these different requirements, we also have different solutions. And we try to place our products and also like other products from competitors into this diagram. And we see here that that we see a trend of third generation overnight charging buses that is coming. So you see here the jump from second generation batteries to third generation batteries. So like the batteries that came from automotive market and with like more than 200 watt-hours per kilogram are also now ready for bus application. And yeah, nowadays you're able to build buses with 600 kilowatt hours without a problem. Yeah, the question from our side is really, do all applications really need this kind of configuration? And how else can we optimize the range of the vehicles, not only with increasing the capacity of the battery? And of course, we also want to show you the high power applications with POSA and the dynamic charging products that we have.
All right, so then I will tell you a bit more about our trolley buses. So as Nicolas said before, it's for the cities with which have already a bit of infrastructure. So for example, catenary lines. Our buses are equipped with lithium titanate oxide batteries from 50 to 75 kilowatt hours. And there are even higher capacities available for double articulated buses, which can then also have more than 200 or around 200 passengers in an event mode. One of our advantages is that with the battery, we can have an autonomy of the bus of around 70%. That means that we just have to drive 30% of under a catenary line where we can charge, and then we can drive without this catenary line, for example, in suburbs or just on lines where there is no such overhead line. Here on the right, you can see a picture from different approaches in some cities. So we have the city center, and in some cities there is a catenary or overhead line just in the city center, and then to drive in the suburbs you use the bus in the battery mode. And in other cities there is even another approach that in the city center you don't want to have these overhead lines because, for example, for crossings it's more complicated, but also just because it's maybe a historical city and you don't want to have these overhead lines. So then there's also the approach to have these overhead lines in the suburbs then. So with this autonomy, we can even do a city-to-city transfer. So there are bus operators which operate in 2 different cities, and they maybe just have one workshop for the 2 cities. So they are possible to transfer these buses from one city to the other. And in general, these buses are used for high frequent bus lines, where nowadays also diesel buses are in operation, and these bus lines can be converted even though there's not an overhead line all along the line. So, and one other interesting feature of these buses is this dynamic charging of the battery. Means that when we are driving under the overhead line, we're not just constantly charging the battery, but we do that in a way that we can have a grid optimized charging procedure. So if the bus is anyway, needs a lot of energy or a lot of power at the moment, we don't charge the battery as well. We then would discharge the battery to support the grid. And on the other hand, we have also a feature that we can detect section insulators. So in every overhead line, you have some intersection between the different grid feeding stations, and if you charge there with high power, some sparks can build when you drive over these intersections. And in this way, we have with geofencing we can detect these areas and also avoid a high charging power there for some minutes. Okay.
Yeah, maybe I can give you a quick showcase also of such a trolleybus or dynamic charging application to really see also the advantages of the batteries that we're using. So battery specs are coming a little bit later, but this is really a key component that we need to make this product. So when you compare or when you imagine a city that has a transfer problem and you need to solve that within a few years, there are different possibilities. Either you can build a light tram in the cities with rails, so you need a lot of construction work where you have construction sites to build all the rails into the street. You can have standard buses like diesel or electric buses with plug charging, or there's also the possibility of trolleybus or other electric BRT systems that we are providing. And yeah, would like to show you what kind of advantages and disadvantages the solution has. So, of course, one very obvious topic is the cost perspective. So, when you read some newspapers or some other articles that are available, you can see that a trolleybus or electric bus rapid transport system is around 10 times more cost effective than a tram or a light rail solution. So you pay around 2 million or something, 2-3 million per kilometer to build a BRT, so a bus rapid transport system. Or you can also pay up to 20-30 millions to build a light tram, a light rail tramway solution. And also the project duration is quite fast. So there's an example of the city in Nancy in France, where we have been awarded in November 2021. Built the vehicle within 2 years, with including developments, so customer specific development, and are going next summer in full operation with 25 vehicles. This is like quite a highly frequented line into the city that is climbing up to a hill where the hospital is located. And it really proves that also then in operation you have quite a high flexibility with construction works in the city center, where you can make a detour with a trolleybus if there is some events or some construction in the city. What is a little bit a disadvantage is that the lines or this traffic this transport solution is not really permanently integrated into the city compared to a tramway. So maybe the value of a tramway station within 100-200 meters close to your apartment is not, or is higher when you have a light tram station there instead of a bus station. So there are some arguments for the tramway solution. And of course, lifetime and passenger capacity is also something where we cannot achieve the same specs like a railway solution. Yeah.
Okay, now we switch over to TOSA. I would say this is an innovative way of charging your bus. It's nowadays called Grid Emotion Flash and provided by Hitachi. We use this solution on our buses, and it was first a prototype that was also supported by the Swiss Federal Office of Energy, and it was a project together with the transport company of Geneva and other industrial partners. So what's the special thing about this charging solution is it's a high-powered charging with a short connection time. So these charging stations can provide up to 600 kilowatts of DC power in just about 3 seconds. So from the moment that the bus stops at the station until the full power is available for charging the battery, it takes just up to 3 seconds max. Then it's providing a 600-volt constant voltage, and so there's an onboard boost converter then to get to the battery voltage. So what you can see here is such a concept of such a line here as an example from Geneva. You have several flash feeding stations marked in green on the right picture. Yes, and then one terminal feeding station. It's this yellow dot. And so the concept is that you have multiple chargers where you just charge up between 10 and 30 seconds. And then at the terminal, you wait a bit longer. It's also where your driver needs a rest, and then you can charge up the battery full again. The advantage is that you can reduce the battery size, and then you have more space for what you want to actually transport, and these are passengers. Here below, you can also see a state of charge profile of such a round trip, and you see these flash feeding stations are just here to power up your battery a bit, and then at the terminal you charge it full again. All right. On the next slide, we will see a demonstration of how this works from an example here in Geneva. So you should see a video. I hope this is fine. So you see the bus is approaching the station, and now this automatic energy transfer system is extends from the bus and is searching for the charging rail, and then it begins to charge. So now the charging power is available, the battery is charged. And then after 20 seconds, the charging stops and the bus can go on. I would say this project here from Brisbane is can be looked as a flagship project for a TOSA application. Hess was awarded with this project and can deliver 60 double articulated buses to Brisbane City. They have fast charging stationed at 2 terminals, and overall it's a bus rapid transport, so there are separate lines for these buses. And Brisbane will be a host for the Olympic Games soon, and then they will also use these buses. Okay, so let's switch more to the battery topics. We use these high power batteries for the trolley and also for the TOSA application. Hess is responsible for the system of the battery and uses batteries from different suppliers. So we are not building them on our own, but we are buying customized or off-the-shelf solution of battery packs. Inside, we have currently Toshiba lithium titanate oxide cells in different configurations from 20 up to 26 ampere hours. And with the nominal voltage, we're somewhere around 700 volts, and we use those batteries in different string configurations from 3 up to 8 strings in parallel. The advantages we see with this technology is that we have a high or a very high cycle life, and we see applications that we can use this battery up to 20 years on the bus. And since we want to use small batteries, for example, for the trolley and the TOSA, we need a high power performance. So power peaks from up to 8 C can happen, and also a continuous charging up to 4.5 C. Overall, there's also the safety aspect. With these cells, we have a very high safety level and also very good performance on low temperatures. Also, there's some downsides of using this technology. It's 3 to 4 times more expensive compared to high energy batteries such as NMC batteries. And of course, the energy density is much lower, so we the weight compared to NMC battery is high. All right, so now we go to our next topic, which is more a bit related to high energy batteries, which we are also using for different applications. So there's overall there's plug charging. So this means that you have the bus operating during the whole day, and then it's been charged in the facilities overnight. You can see such an example of a state of charge profile on the left side. So the battery is continuously discharging, and then in the night hours, it's been charged up. On the other hand, there's also this opportunity charging, means that along the line you have some charging infrastructure where you can charge up your bus during the day. There are different approaches. Some use this quite often. They make a mix between plug charging and opportunity charging. The capacity that has to be installed on the bus are roughly around 300 to 800 kilowatt hours in these applications. And we are currently using NMC batteries. When we go into opportunity charging, as I said, it's occasional recharging during the operation. They are charging infrastructure at the terminals or even at intermediate stations, and mostly the stop needs to be a bit longer than 5 minutes so that you can charge there. And the charging power is not as high as, for example, in the TOSA application, it's around 150 to 450 kilowatts. And then I think an important thing to note is also the connection time. So before I talked about a connection time from about less than 3 seconds, and with this opportunity charging, we are more in the range of 40 seconds until we really see a current flow of the connection. So there are two different approaches. You see on the right side, pantograph up means that you have a moving part installed on the bus, which is then connecting with your charging infrastructure. I think there's one big advantage of this technology is that if one of these pantographs fails, there's not your whole fleet involved in this. So it's just the bus that has a failure with the pantograph needs to be replaced. And in general, the infrastructure is a bit less complex and therefore also less expensive. Then also to mention is pantograph down. So the moving part is on the infrastructure side, and then you don't need that much space on the bus for these pantographs, and also you have a lower height of the bus overall, and in general less equipment, which means again less weight and more space for passengers. Yes, thank you. So if somebody wants to ask me what's the better solution, overnight charging or opportunity charging, I would refer to this to these studies that has been done by McKinsey, and it shows, yeah, it strongly depends on the scenario. So first of all, for short distances, we see we have a winner there. So overnight or the depot charging is a bit less expensive than opportunity charging. But on the other hand, if we go to a medium distance range, so 30 kilometers of route, also 300 kilometers per day, I think the winner there is opportunity charging. So as a take-home message, yeah, there's not a clear winner, but it strongly depends on the scenario. Okay.
Yeah, so this is a very good preparation for our to show you our next project. So we have seen that especially lines where you don't have huge mission profiles, overnight charging is a suitable concept. And with this concept, we are also in a new BFE project or project supported by the Federal Office of Energy, where we really want to showcase that that you can replace electric buses, or you can replace diesel buses with battery electric buses. And our key action points in this project are that we have an optimized traction architecture with a new battery, also with increased charging power of the plug charging, and also an increased efficiency of the HVAC systems, of the whole system that provides thermal comfort in the passenger area. And we're also doing some optimization for the battery and the infrastructure concepts. So there are like tools that are developed in this project. What is very important is that we say yes to bigger batteries, with higher energy density on the bus, but always together with a more efficient HVAC system, because we are, especially in the bus where you have a big passenger compartment, quite a big energy consumption for the thermal comfort. And with diesel buses, we were able to use the dissipated energy from diesel motor to heat up the passenger compartment. But with electric buses, this energy always comes from the batteries. And for us, it's important, and this is in our battery electric vehicles, overnight charging vehicles, that we want always to make two steps together, optimizing the energy efficiency of the vehicle and also increasing the battery capacity. Yeah, so there is an interesting study from that also shows the market expectations of the ranges of electric buses in the future. So when we have a look into next year, 2024, market, and also like some key players on the Swiss bus market want to have up to 250, 300 kilometers range. Also in winter, and winters in Switzerland can get quite cold and harsh. And this is where we want to achieve with our new concept a range of 300 kilometers. And this is foreseen to prove that with buses that are coming next year. The project is together. The first bus that we're building like this is together with the public transport company of Zurich, and research partners from ETH and Bern University of Applied Science. So, and also we can then prove this 300 kilometers in winter conditions with an articulated bus. For the standard 12-meter bus, we have some limitations, but also 250 kilometers should not be a problem with all the new innovations that we include in this project. So generally speaking, we can say we are a little bit ahead of the market expectations in terms of the range of the vehicles. Yeah, one interesting question that we have also asked during the project is how would a chatbot like GPT make an electric bus more energy efficient? And this is a question that I've asked in 2 months ago, and you can see the results are quite interesting. That there were like 11 approaches to make it more efficient, and 4 of them we have already implemented in our standard products. 3 of them are covered also with this new innovation project. 2 of them we are thinking about it, what we should do with that. So predictive maintenance and solar panels. Yeah, maybe we are doing some potential studies on that, and the other 2 we cannot really impact. Tire designs and driver training is something that is not in our hands, or we can not really influence too much. Yeah.
All right. So Next, I want to show you a bit the step size we made with the change from Gen 2 NMC batteries to Generation 3 NMC batteries. So our idea was to implement the latest or the newest generation of high energy NMC batteries that are available on the market as a battery pack. So in terms of kilowatt hours installed per battery pack, we jumped from 60 or 66 or up to more than 100. But what's maybe more interesting is the gravimetric energy density and also the volumetric energy density. Both values are very important for us, since the weight or the overall weight of the bus is limited, and we cannot drive with buses that are 40 or 50 tons. So we are restricted there to a limit, and with these Gen 3 batteries, we had an improvement of plus 17% in terms of gravimetric energy density. But on the other hand, also the volumetric energy density is important for us. So as Nicolas told you before, all our batteries are placed on the roof, and there are also other components placed on the roof, such as air conditioning systems and other traction components. And so it means the space on the roof is quite limited. And with these Gen 3 batteries, we could improve the volumetric energy density as well, plus 44%. So with these improvements, we should reach the goal of having a bus that can reach these ranges we saw before.
And what is maybe really interesting again, so this 17% of more gravimetric energy density, it's always together with the energy efficiency that we want to increase with the innovative HVAC system and the thermal insulation of the vehicle. So together with both measures, so increasing energy density and increasing energy efficiency, we make like a jump from the ranges from around 200 kilometers per day up to 300 kilometers per day. So yeah, there we can see quite a big new step of the electric range of these electric buses.
So as already mentioned in the introduction of the projects, we also do testing of the cells at the laboratory of BFH, and the motivation there is that we know what are the specific aging mechanisms of these cells that we are using. With the results that we are gaining from the tests, we want to optimize the battery use of the bus. So, for example, if we know that a certain discharge behavior is not very good for the cell itself, we can adapt the battery usage on the bus. And as well, what's very important is the lifetime expectancy, that we know how long this battery can operate on our buses in certain conditions. And then we can also plan the replacement accordingly together with the bus operator, and also trying to help in adaptation of the operation in order to optimize this. So the procedure, let's say we have this results from the degradation results from the cell test. We would then like to define stress factors, some certain factors that describe what is the influence on the aging. And then we build up a model that is operating on OpenSesame. So it's an OpenSesame solution that is an open source simulation tool, semi-empirical simulation tool from BFH as well, that we can use there to build up this whole model of the battery.
Yeah. This here is a slide that we maybe can show you in summer next year. This is the optimization measures that we implemented in the new innovation bus. Yeah, but results are not ready, but yeah, we are looking forward to show that to you, what kind of achievements we have here. So together, the insulation of the whole body of the vehicle, and also an optimized thermal management are very important to for our new electric buses.
So, and last but not least, one aspect of this project is also the research question, which charging strategy is optimal for an entire fleet of electric vehicles. And there is mostly the ETH of Zurich involved, and it's all about the optimization of the dimensioning of the battery and the infrastructure. This also includes the timetables of the bus fleet and also the passenger volume that occurs on these specific lines. And but it should be a model then that can be used on different bus lines, even at different bus operators. And then a goal is to modeling the battery options in terms of size, cell chemistry, age, etc. And what will be available open source is also a toolbox with different tools that helps you to answer those questions, and it's called OCCEPT, and this will be, as I said, available open source.
So maybe to come to a conclusion of these different questions of which charging option is the best, with battery concept is the best. Yeah, it's like always. So there is not one solution that fits all. It's very important to identify the requirements or the line profiles, the mission profiles of the different lines, and also of the overall fleet, that you really can make a good choice of the battery and charging technology. So yeah, some assumptions that we made are that cities who already have a good trolley bus network should extend it or use it also for diesel lines that are under this catenary network. So a few cities in Switzerland are already doing that. Also in France and in Austria, we have some projects where we can see that. And especially for cities who have a transport problem, we can also solve this problem with a transport solution. So we are able to make line simulations for different lines, then compare the different concepts, compare total cost of ownership, and also then propose a possible concept, either TOSA or opportunity charging or depot charging, depending on the different line and fleet requirements that the different transport companies have. But often you can say that there's like a heterogeneous fleet of different charging technologies is always a good way to go. So you always have some lines who are not where you maybe drive 150 kilometers per day, and sometimes where you drive 300 kilometers per day. So you need, maybe not the same like you have a diesel bus, and the diesel bus can drive all the lines. So yeah, maybe it's necessary to also mix the fleet a little bit with different vehicles that can drive different missions, different line missions. Yes. Okay. And maybe first of all, or first again a little showcase. It was an old one.
Oh, yes.
Okay. Before the conclusion, again a showcase why we're always promoting this opportunity charging, this flash charging, and small batteries. So we made an easy calculation here with a fleet, an example of a fleet with 80 vehicles. So yeah, mid-sized city in Switzerland, I would assume. And the goal is to have 4 lines operated by these 80 vehicles. and run this lines for 20 years. And there's one option where you can see with electric bus solutions with around 600 kilowatt hours with overnight charging concept, where we discharge the battery around 70% in average, and the vehicle has a lifetime of around 14 years, and you need to invest around 4 million for the depot charges in your depot. And the second option is that you implement a transport system where you have advanced battery and charging technology. So where you make a higher invest in the beginning, where you invest in charging infrastructure on the line, where you also invest a little bit in a high price of the vehicles because of the little bit more expensive batteries. So if you have 120 kilowatt hours of LTO batteries, for example, on this solution, the investment in the beginning is bigger. But what we can see when we do a TCO calculation, we have a cost saving of around 30–35% compared to option one. So at option one, you're also replacing the batteries 2 times, so 1 time after 7–8 years, and again after 14–15 years. And you then also use a lot of resources for building these batteries. So compared to 120 for 20 years, compared to 1.8 megawatt hours over 20 years, it's a lot of batteries that are not produced with option 2. And this, I think, is also a key takeaway of our presentation, that if you make a clever transport concept, a clever public transport concept, you can also make a big influence on the sustainability of the fleet, of the resources that you use to implement such a fleet. And some recommendations from our side are also listed here, so that at least battery lifetime should be higher than 8 years. And also the vehicle lifetime, we propose to have it higher than 16 years, because we don't see a really reason to keep the vehicles only 10–12 years. I think this was coming very much from the diesel bus world, where you had to replace the buses because of new emission standards that came out, like move from Euro 4 to Euro 5 to Euro 6. There was always new emission standards that were coming, and then transport companies were like forced to change the vehicles after every 10–12 years, and we don't really see this short lifetimes for electric buses. And also one smaller advantage of charging during the day and while driving is that you can also use the energy that is produced by photovoltaic plants or photovoltaic energy that is available, and during the night this is not available, and that's when normally overnight charges are charging up again. So back on the conclusion, what we see is like 4 different concepts that are very interesting for us, and also for bus operators, that we will have for cities that already have an advanced charging infrastructure. They can implement very easy this different dynamic or TOSA charging, or also upcharging. We see also here that this upcharge concept is going to a third generation, where we can maybe have again like new concepts where you can allow maybe charging only 1 or 2 times per day, or during noon time when there is not a lot of traffic and driver has a little bit more time at the terminal station to charge it up. But I think the main advantage is that you don't have the big DODs over the day. So you have maybe discharging the battery like 40–50% until noon, and then charge it back up to 70–80%, and then driving again until midnight. And yeah, then you can prevent 40–50% of a charging cycle in the night. And what we also see, especially in less dense areas, is this plug charging approach that we want to showcase with the Swiss eBus Plus project. So overnight charging is important. There need to be solutions, but we think it's important that there are solutions that are very energy efficient, that we don't waste energy for the thermal comfort, and use the kilowatt hours for driving and not for heating the environment.
So maybe just a small wrap up from battery perspective. So we talked about LTO batteries, so high power performance but less energy density. On the other hand, we also use NMC batteries, higher energy density but less power performance. Of course, there's also a spot between, and I think we're quite open-minded also for new technologies, whether they fill this gap in between, or as you see here on the slide with this golden egg. So we haven't, there's not Christmas yet, but we are also already thinking about Eastern. So help us to find this golden egg in the charter of this battery performance and energy density. So and of course long life. So we're very open-minded also to see new solutions there.
Yeah, I think this is the last slide. Thank you very much already for listening. Yeah, maybe we can hand over again to Christian if you want to have a short Q&A session.
Yeah, we have basically only 1 minute, but I think we can do 2–3 minutes more. Thank you very much for this interesting insight. First of all, I was very happy to see that you don't sell any diesel buses anymore. I think this is really exciting. And I thought when we go back to the last slide that Marco was showing, I think maybe lithium iron phosphate batteries could be interesting, because we see more and more they allow high charging currents. Well, the energy density is certainly a bit lower than NMC, so I think that could be maybe a solution in between the LTOs, maybe not like shown in the picture on the same level as LTO, but I think somewhere filling that gap. I see that Andreas Fuchs has a question. I think the easiest is when you type it into the chat, but what I can do, I can allow you quickly to use the microphone.
Thank you. Your bus is living 20 years. And the battery business is very dynamical. How can you assure replacement batteries or guarantee the customer that they will have replacement batteries that are optimal also in 10, 15, 20 years?
Yeah. So I think anyway, as a vehicle manufacturer, we have to provide original equipment at minimum for 10–12 years. So this is normal. So every car manufacturer and truck manufacturer needs to provide spare parts 10–15 years, and this is what we're doing. So we try not too much to change our interfaces on our battery packs. That we will have some retrofits, especially for NMC projects in the future, and we always try to then have the best mix between vehicle lifetime and battery lifetime. So when we see electric buses that have a lifetime of 16 years, maybe we try to make the battery change if necessary after 8–9 years. And we only use 2 batteries over the whole lifetime.
Okay, thank you.
This is a spare part that is available and also calculated from our side.
Thank you.
Okay, do we have more questions from the audience? Please raise the hand. I think it's the easiest, or write into the chat. We have another question. I don't know, it's just written fast. I don't know from who this is. Do you think the limitations on the use of rare earths will have an impact on the development of gravimetric energy densities? Well, I think there are no rare earths directly included, also directly in batteries. Right? Maybe in the battery management system or something like that, but yeah, not in the battery cell materials.
Yeah, maybe we can answer this question in the way that, as Nicola explained, for us it's not the bigger the better. So try to optimize the battery size in the way that we don't need that much of battery capacity, especially when we have infrastructure to use, or which we can use. And I think just in some applications, then you need maybe a big high energy batteries.
Yeah, I think it's important that if some kind of off charging or closer charging or dynamic charging is possible, you should really try to do that and really try to implement that, because you can save up to 15 times battery capacity, battery raw material that is not used, and I think this is the important takeaway, and maybe also in terms of this cobalt discussion, we are open to discuss other technologies like proposed by Christian with LFP, or also with the Shen 3, we are going into a more nickel-rich solution, and also minimizing the critical raw materials, I would say.
Excellent. Well, I think if there are no new questions, I would actually close this Q&A session and stop the recording here.